Have you ever looked up at the night sky and wondered if we are alone? We often think of Earth as the perfect home. Our blue marble is a paradise, a unique cradle for life in the vast, dark emptiness of space. It has everything we need: water, air, warmth. But what if I told you Earth might not even make the top 10 list? What if there are other worlds out there, scattered among the stars, that are even better suited for life than our own planet? It's a bold idea, I know, but science is all about asking bold questions. And this question might be one of the biggest. In this journey, we're going on a cosmic safari. We will count down the top 10 most habitable worlds we know of. These are planets and moons that could, in theory, offer a more stable, a more nurturing environment for life to begin and to thrive. We are not just talking about places where tiny microbes might survive. We are talking about worlds that could be super habitable. Worlds that make Earth look a little less special. This isn't science fiction. This is based on real data from our most powerful telescopes and our deepest understanding of how life works. Prepare to have your perspective shifted. We will travel light years away from our solar system. We will explore planets orbiting stars very different from our sun. Some will be older and calmer. Others will offer more consistent energy. For each world on our countdown, from number 10 all the way to number 1, we'll uncover its secrets. I'll give you a quick comparison to our home planet so you can see exactly why it makes the list. We will also discover one stunning, mind-bending fact about each destination that highlights its unique potential. This cosmic countdown is designed to be an adventure for your imagination, grounded in the reality of scientific discovery. Each stop on our tour will be a short, engaging exploration of a new frontier. We'll break down complex ideas into simple, clear concepts. You don't need a PhD in astrophysics to join this expedition. All you need is a sense of curiosity and a willingness to look at the universe in a new way. So, buckle up. The tour is about to begin, and our first stop is just around the corner. Are you ready to question everything you thought you knew about our place in the cosmos? Before we blast off, we need to agree on the rules of the game. What does better for life even mean? It's not just about finding a planet that looks a bit like Earth. We need a clear scientific checklist. We've boiled it down to 5 simple but crucial criteria. These are the ingredients for a truly habitable world. The first, and maybe the most obvious, is temperature. A planet needs to be in the Goldilocks zone of its star. Not too hot, not too cold, but just right for liquid water to exist on its surface. Without liquid water, life as we know it simply can't get started. Next up is water itself. It's the solvent of life, the medium where all the magic of biology happens. A world that is better than Earth would likely have more liquid water and have it more consistently available across its surface. Then there's the atmosphere. A protective atmospheric blanket is essential. It needs to be thick enough to shield the surface from harmful radiation and keep the climate stable, but not so thick that it creates a runaway greenhouse effect like on Venus. Our fourth ingredient is energy. All life needs an energy source. We're looking for a reliable, steady power supply that can fuel a global ecosystem for billions of years. This brings us to our final, and perhaps most important, criterion: stability. Earth has faced ice ages, asteroid impacts, and supervolcanoes. A truly better world would be calmer. With these 5 criteria in mind: temperature, water, atmosphere, energy, stability, we are now ready to begin our countdown. We will judge each world against this cosmic scorecard to see which ones might truly be a paradise beyond Earth. Our cosmic countdown begins with a planet that was once hailed as Earth's twin. Kicking off our list at number 10 is Kepler 186f. This world is located about 500 light-years away from us, orbiting a cool, dim star known as a red dwarf. What makes Kepler 186f so special is its size and position. It's only about 10% larger than Earth, making it likely a rocky planet with a solid surface. It orbits within its star's habitable zone, the region where temperatures could allow liquid water on the surface. Its position is on the outer edge of the habitable zone, so it might be a bit cooler than Earth on average. Think of a world in a mild global autumn. Plants might not be green like ours. On Kepler 186f, plants might evolve to be black or dark red to capture more red-shifted light. That could create a visually stunning alien ecosystem, similar enough to be familiar, but different enough to be exotic. So why is it only at number 10? There are still many unknowns. We don't know if it has a substantial atmosphere, or if its star produces violent flares that could strip it away. The striking fact, Kepler 186f was the first Earth-sized planet discovered in another star's habitable zone. It proved worlds like ours exist, waiting to be found. Moving up one spot to number 9, we encounter a planet called a super-Earth. Meet Kepler 442b, located about 1/200 light-years away. It's significantly larger and more massive than Earth, about twice our planet's mass and roughly 1.3 times its radius. A larger, rockier planet would have stronger gravity, making it better at holding a thick, protective atmosphere. It would likely have a more active geology. Kepler 442b orbits a star slightly smaller and cooler than our Sun, a K-type star, an orange dwarf. These stars are often seen as ideal hosts for life. They're more stable than volatile red dwarfs. And they also live far longer than Sun-like stars. Its orbit is very circular, so it avoids wild seasonal swings. Stronger gravity and active geology could yield a long-term stable climate. Unlike Earth, which has seen global ice ages, Kepler 442b might keep consistent temperatures for billions of years. It's like a house with a perfect, self-regulating thermostat, far steadier than Earth's temperamental climate. So what's the striking fact? One habitability index gives a 97% chance Kepler 442b lies in its star's habitable zone. That's one of the highest confidence levels we have. It checks almost all the right boxes on paper. As a theoretical paradise, Kepler 442b stands as a powerful example of a world potentially better than our own. At number 8, we journey to a truly remarkable and famous planetary system. Welcome to TRAPPIST-1, located a mere 40 light-years from Earth. This system is incredible because it's not just one planet, but 7 Earth-sized worlds. The planet we are interested in is TRAPPIST-1e. It is almost exactly the same size as Earth and is believed to be a rocky world. Life on TRAPPIST-1e would have a spectacular view. From the surface of TRAPPIST-1e, the other planets would appear in the sky as large disks. Some would look as large as our moon, or even larger. Imagine looking up and seeing several other worlds hanging in the sky. The close proximity also means that if life evolved on one planet, it could potentially spread to others via meteorites, a process called panspermia. However, recent models suggest that a thick enough atmosphere could distribute heat from the day side to the night side, creating a stable and habitable climate. Here is the stunning fact about TRAPPIST-1e. It is so close to us, cosmically speaking, that our next generation of telescopes, like the James Webb Space Telescope, can actually study its atmosphere. Scientists are actively looking for the chemical fingerprints of water, methane, oxygen. This means that within our lifetimes, we might get real data that tells us whether this world truly is a habitable oasis. The possibility of finding proof of an atmosphere, and maybe even life, on this world is what places it firmly at number 8 on our countdown. Climbing to number 7 on our cosmic countdown, we arrive at a destination that is practically on our celestial doorstep. Meet Proxima Centauri b, our closest known exoplanet. It sits just over 4 light-years away, a stone's throw in galactic terms. The planet orbits extremely close to its star, completing a full year in just 11 Earth days. The intense gravity likely tidally locks the planet. The biggest problem is the star itself. Proxima Centauri is a very active flare star. It frequently unleashes powerful bursts of radiation. Those flares could devastate surface life. Any life would have to be incredibly resilient. It might live underground, or in deep oceans shielded from the outbursts. Its proximity is its greatest asset. Being our nearest exoplanet neighbor lets us study it in unprecedented detail. It's the target of projects like the Breakthrough Starshot Initiative. If we could travel at Parker Solar Probe speeds, it would still take over 6,000 years to reach Proxima b. That fact highlights the immense scale of space and underscores the challenge of interstellar exploration. Section 2, Countdown 6, Wolf 1061c, a super-Earth in the neighborhood. At number 6, we find another relatively close neighbor. It orbits a red dwarf star called Wolf 1061, older and much more stable than the volatile Proxima Centauri. This is a huge point in its favor. Wolf 1061c is what we call a super-Earth, with a mass more than 4 times that of our own planet. This geological activity is crucial for regulating a planet's climate and cycling nutrients, processes that are vital for sustaining a global biosphere. The planet orbits its star in about 18 days, placing it on the inner edge of the habitable zone. This means it could be warmer than Earth, perhaps with a more tropical or humid global climate. However, this position also comes with a risk. Like Proxima b, Wolf 1061c is likely tidally locked. This could create a runaway greenhouse effect on the dayside. Here's the mind-bending fact. It is one of a trio of planets in its system. Their tugs and pulls might help prevent the planet from becoming perfectly tidally locked, possibly allowing it to have a slow rotation and a more distributed climate. This complex dance between the 3 planets could be the key that unlocks its full habitable potential, making it a dynamic and fascinating world to consider in our search for life. Section 4, Countdown 5, breaking into our top 5, Earth 2.0. At number 5, Kepler 452b, strikingly similar to Earth. Its year length, 385 days, almost the same as Earth's 365-day year. What ranks it so high? Its age. Its star is about 1.5 billion years older than our Sun. If life arose there, it had 1.5 billion extra years to evolve. Imagine another billion years of evolution, and complex ecosystems beyond our own. But here's the question mark. Given its age and slightly higher stellar energy, Kepler 452b could be undergoing a runaway greenhouse. Or, if its larger mass retained water and climate stability, it could be a glimpse into Earth's future, a mature, evolved world, a potential paradise perfected over extra time, a powerful number 5 in our countdown. Countdown 4, Kepler 1649c, the hidden gem. Our journey now takes us to number 4 on the countdown, a planet that was almost missed entirely. Meet Kepler 1649c hiding in old Kepler data. This cosmic hidden gem is located about 300 light-years from Earth. It resembles Earth in several key ways. 1.06 times the size of Earth. It orbits a red dwarf star, sits squarely in its star's habitable zone, receives about 75% of the light Earth gets. That energy could allow liquid water on the surface. It's considered the most similar exoplanet to Earth in size and in estimated temperature, discovered by Kepler. Other planets might be closer in size or closer in temperature, but not both. But Kepler 1649c's star appears mature and quiet. A calm star is a huge advantage. A planet around a stable red dwarf has a much longer future. The star will burn steadily for hundreds of billions or even trillions of years. A global weather system would form, creating a wide habitable band, the permanent twilight zone. The red sun would hang motionless, never rising, never setting. The result? A stable, predictable, and potentially nurturing cradle for life. Arriving at number 3 on our countdown. Welcome to Teegarden's Star B. This planet is incredibly close to us, just 12.5 light-years away. It orbits an ancient, ultra-cool red dwarf. This star is exceptionally calm and stable, and has been around for at least 8 billion years. Teegarden's Star B is very similar to Earth in mass. Its gravity would feel almost identical to home. One exciting metric is the Earth Similarity Index, or ESI. Teegarden's Star B scores 0.93 on the ESI. On paper, it's a true terrestrial cousin. The single stunning fact, scientists estimated a 60% chance of temperate liquid water on its surface. That was a statistical probability, not a guess. This high likelihood plus age, stability, Earth-like mass, makes it a top-tier candidate, potentially even better for life than Earth. We have reached our runner-up, the planet that takes the number 2 spot in our cosmic countdown, the planet known as TOI 700d. This was the first Earth-sized planet to be discovered in the habitable zone by NASA's TESS satellite. TOI 700d is about 20% larger than Earth. It orbits a cool M-dwarf star, much quieter and more stable than many of its red dwarf cousins. One of the most significant facts about TOI 700d is that it is tidally locked. We know this with a high degree of certainty. However, scientists have been able to run detailed 3-dimensional climate models to simulate its environment. These simulations have produced a very optimistic picture. This leads us to the striking fact that secures its number 2 position. One of the most likely scenarios for TOI 700d is a world completely covered by a global ocean. On the star-facing side, a thick cloud layer would form, creating a stable, temperate climate below. A massive liquid ocean on one side, the other side frozen solid. Life could thrive in this vast, sunlit ocean, powered by a star that never moves in the sky. It would be an aquatic paradise, making it a spectacular silver medalist in our search for a better world. But now we have arrived at the final stop on our cosmic countdown. The moment has come to unveil the world that holds the number 1 spot. The planet that is not just habitable, but truly super habitable. A world that could be, in almost every way, better than Earth. It orbits a star that is a near-perfect twin to our Sun. It avoids tidal locking, it avoids harmful stellar flares. The planet at the top of our countdown is Kepler 22b, located about 640 light-years away. Its year is 290 days long, giving it seasons and a calendar that are remarkably close to our own. The most captivating theory about Kepler 22b is the possibility that it is a water world or an ocean planet. This would create an environment of unparalleled stability, a planetary cradle where life could flourish undisturbed for eons. The striking fact that cements Kepler 22b as our number 1 is its position in the habitable zone. An estimated average surface temperature of about 22 degrees Celsius or 72 degrees Fahrenheit. This, combined with its potential as a stable, massive ocean world orbiting a sun-like star, makes it the ultimate destination. It is the gold standard for a super habitable world. Our cosmic journey is now complete. We have traveled across the galaxy, counting down 10 worlds that could be even better for life than our own. This exploration of super habitable worlds is not about abandoning Earth. It is about gaining perspective. Understanding what makes a planet better helps us appreciate the delicate and precious balance that makes our own world habitable, reminding us of our responsibility to protect the only home we have. The James Webb Space Telescope is already studying the atmospheres of nearby worlds, and future observatories will be even more powerful. The search for life beyond Earth is one of the grandest adventures humanity has ever undertaken. It is a quest that unites us, transcending borders and generations. So, the next time you look up at the night sky, remember what might be looking back. The universe is not a dark, empty void. It is a vibrant, dynamic, and creative arena, filled with more wonders than we can possibly imagine. Our countdown is over, but the real journey, the journey of exploration and discovery, has only just begun. Let's keep looking up. Let's continue to wonder.